What is a homogeneous differential equation? Now, a homogeneous differential equation is basically one of the form dy dx equal to f of y over x. Now, these equations cannot actually be solved by normal method. That is because the variable x and y, they are actually inseparable. You cannot actually separate them from each other within this function. So you actually need to find another function or another equation and find a new variable for that equation that would hold in terms of y and x. Let's say a variable as v. And let's say v is equal to y over x. So that is actually what you're going to do. Now, a homogeneous differential equation could also be represented in this form. That is f of lambda x comma lambda y is equal to lambda to the nth power multiplied by f of x comma y, right? So this form is actually very useful in finding out whether or not an equation is a homogeneous differential equation. So let us start with the proof. Let's see that, okay, I just need to wipe this first off. So we know that for that you should have f of lambda x comma lambda y should actually be equal to lambda to the nth power multiplied by f of x comma y, right? So let us try some examples. Let's say you were given this example. F of x comma y is equal to x to the fourth minus x to the third y. You are asked to find whether or not it is a homogeneous equation. So let us try to do it. So we're actually going to change these forms and introduce a lambda x and a lambda y. So that is now going to be f of lambda x comma lambda y. And so x here should actually be changed to lambda x. So this is going to be lambda x, which should be raised to the fourth. And here we're going to have lambda x to the third. And for y, we would have lambda y. So if we distributed the fourth power to each term within this, we're actually going to have lambda to the fourth multiplied by x to the fourth. Then this will be minus lambda to the third multiplied by x to the third. And this should be multiplied by lambda multiplied by y, right? So we have lambda to the fourth multiplied by x to the fourth. This is minus lambda to the third plus 1. Now, why is that? We already have this lambda, which is actually raised to the first power. So if you were meant to multiply this with this, then basically you need to add the powers, 3 and 1. So that will give you 4. And this will be multiplied by x to the third multiplied by y. So what we should have here should be lambda to the fourth multiplied by x to the fourth. And this will be minus lambda to the fourth multiplied by x to the third multiplied by y. So what do you think can be done from here? Now, obviously from here, we have lambda to the fourth for the first term and also a lambda to the fourth for the second term. So we can actually factorize. Let me quickly wipe this out. So this is what we're going to have. I can factor lambda to the fourth out, and that will give me x to the fourth minus x to the third y. Now bear in mind that x to the fourth minus x to the third y, that is actually the function f of x comma y. And that is exactly what we were trying to say. For that equation to be a homogeneous equation, you must actually come back to form f of x comma y. then you should be able to factor out lambda raised to a common power. In this case, the power is 4. So we're actually going to say that the function x to the fourth minus x to the third multiplied by y, that is actually a homogeneous equation or a homogeneous function of the degree 4 or of the fourth order. So that is basically it. Now let us try another example. So let's say in this case, you are given something like this, x squared dy plus y squared minus xy dx. And this were equal to 0. So what is going to be the answer? Should this equation be a homogeneous or not? So let us find out. Now, for homogeneous functions, you could actually have this form or this other one, where there is actually going to be a dy dx, and that is equal to f of y over x, right? So even if we had this, this would actually work. So dy dx is the same thing as f, and that is going to still be the same thing as f of x comma y. So just hold that at the back. So first thing I need to do, I need to take dy dx and have it appear in this equation. So how am I going to do that? I have dy here, and here I have dx. So what I need to do, I need to take dx and divide it through to each part or term within this equation. So here we're going to have a x squared dy divided by dx, and here we're going to have a y squared minus xy dx divided by dx, and here we would have a 0 divided by dx. Now obviously this can cancel out, and anywhere you have 0 divided by anything, that basically takes you back to 0. So this is what I'm going to have. X squared dy dx, this is plus y squared minus xy, this is equal to 0. So the next thing I need to do, I need to make sure that dy dx is actually isolated. So the next thing I need to do, I need to take this to the other side. That is the first step. So that will leave me with x squared dy dx on the left hand side. And on the right, we're going to have a minus y squared minus xy. Okay. So I just need to rewrite this. This is the same thing as f of x comma y. So now with this, the last thing I need to do, I need to take this to the other side. That basically should be by multiplying with the reciprocal of x squared, which is actually 1 over x squared. This is multiplied by x squared dy dx, and here we're going to have 1 over x squared multiplied by minus. Now instead of doing that, I know that minus 1 multiplied by y squared is basically going to give us minus y squared. Minus 1 multiplied by negative xy, that should give us a positive. So a positive xy comes before a negative y squared, right? Yeah, so that is what we have there. Now over here, I know that x squared will cancel out the other x squared. So we should have dy dx left on the left hand side, and here we're going to have a xy rather, minus y squared divided by x squared. Now this fraction could be splitted into this. So this is what you have. Now I know that x can cancel one of it here, and here stuff is just going to remain there. So this is what we're going to have. I know that dy dx, could be written as f of x comma y. So this is going to be f of x comma y. Now on this side, I have y over x minus y over x, but this is all squared. Now, as you know, I need to make this function be replaced with this type of function. So there should now be f of lambda x comma lambda y. So that is going to be f of lambda x comma lambda y. So everywhere I see y, there should be a lambda y instead. And here, where I see x, there should be a lambda x. So that is what I had there. I might well just remove these brackets. Then over here, I have lambda y over lambda x, and this is also all squared, right? So for this, I know that this is going to be lambda divided by lambda, which basically should be lambda raised to the power of 1 minus 1 from indices, right? So that should give us a 0. This is lambda to the 0, and we have it multiplied by y divided by x, right? Now on this part, I actually have this being distributed. So this is going to be lambda y all squared. This is divided by lambda x all squared. So I need to wipe this out. Okay, let me take it back because I would actually need it later on. Now, this is actually going to be lambda to the 0. We have y over x. And over here, I'm actually going to have lambda squared multiplied by y squared. And this is divided by lambda squared multiplied by x squared. So what is that going to give? I know that this is going to be lambda squared divided by lambda squared. So obviously that should give us lambda to the 2 minus 2. That gives us a 0. So this is what we're going to have. Lambda to the 0 of y over x minus lambda to the 0 here. And this is also going to be y over x. Obviously, this goes back to all squared because we're actually going to have y squared divided by x squared. Now, as you can see, we can factor out lambda to the 0 as well as what we have on this other side. And that goes to find something like this, which is actually the condition that is required to find whether or not an equation is actually homogeneous. So what if I did that? What is it going to give us? So this is actually going to give us lambda to the 0th. And here we're going to have y over x minus y over x all squared, right? And this is exactly what we were talking about. This is actually f of x. We have f of x being equal to y over x minus y over x all squared. Now we know that what should be there is that anytime you plug in f of lambda x comma lambda y, you should actually have a lambda that will be factored out in common terms. So the powers of lambda should actually be the same for both terms within that expression or function. So this is actually also a homogeneous equation of the degree 0. So this is for the 0th order. Now this could be written as f of lambda x comma lambda y. So that proves it. Now let us try one more question where you would actually find that the equation wouldn't be a homogeneous. So let's say you were given this one. F of x comma y is equal to x squared plus sine x cos y. Now, of course, we need to apply f of lambda x comma lambda y. So over here, we're going to change x to lambda x and square everything. Then on this side, I'm going to have it as a lambda x This is multiplied by cos lambda y. Of course, for this one, we should actually have lambda squared multiplied by x squared. But for this, we cannot actually take lambda away from the sign, neither can we take it away from the cosine. That is because the angles are actually different, and there is no trigonometric identity that would actually take us to finding how we could take lambda away from here. Because if that were possible, that then will be lambda multiplied by lambda, which would actually create a lambda squared, the same thing as you have here. And that should have been a homogeneous equation. Unfortunately, we do not have that because these are actually impossible. You cannot actually solve them because the angles, they're actually different, right? So for this one, we say that this is actually not a homogeneous equation. Now, having got that, how can you solve a homogeneous equation? If you are able to find out that an equation, or a differential equation rather, is actually homogeneous, how can you solve it? So we know that for a homogeneous equation, in basic terms, dy dx should be equal to f of y over x, right? Now, since we know that y or v, neither of them can actually be separated from the other, we actually need to introduce another variable. So we said in that case, let v be equal to y over x, right? So that is going to make dy dx to be written this way. That is going to be f of v. So these two, they're actually the same. They're actually equal to each other because of this provision. Now, just hold that at the back. So that makes it be that we have dy dx is the same thing as f of v, right? Because we have v to be the same thing as y over x. Now, we know that v is said to be y divided by x. Now, if I wanted to make y the subject, that is going to be v multiplied by x. Now, what if I wanted to differentiate both sides of the equation? So for this side, that basically should be dy. Now, on this side, that will be a differential by method of products. So that should be v dx plus x dv, right? Now, let us divide through by dx. So if we do that, this is going to be dy dx, and here we're going to have v dx divided by dx, and here we're going to have x dv divided by dx. So we know that this is going to cancel out, and we're going to have a dy dx, and this will be equal to v plus x dv divided by dx. Now we already know that dy dx, that is the same thing as f of v, right? So I'm just going to replace that with f of v. So this is going to be v plus x of dv dx. Now next up, I need to take v to the other side. So this is going to come in this form. This will be f of v minus v, and that will be x multiplied by dv dx. Now, can you notice any irregularity here? There is actually something here that should not be there, dv. So we want to take dv to the side where it's most likely supposed to be. So how can we do that? How can we take dv away from the right hand side and take it to the left? So that basically should be done by multiplying with the reciprocal of dv. So that is going to be 1 over dv multiplied by f of v minus v. And that should be done on this other side. So this is going to be x dv divided by dx. multiplied by 1 over dv. So this cancels out, right? So that leaves us with f of v minus v divided by dv. That is going to be equal to x divided by dx. And the last thing we need to do, we just need to flip this equation. This equation, we need to flip it. So that will give us something like this. dv divided by f of v minus v, and that is going to be equal to dx divided by x. This is actually the formula that is majorly used in solving homogeneous equations. So with that in mind, let us try solving this question. So let's say that you are given this question. Let's wipe this. So this is dx, and this is plus 2xy dy, and this is equal to 0, right? So first off, let us write out some precedents. We know that dy dx is the same thing as f of v, right? Or is the same thing as f of y over x, right? Now we also know that the formula to be used is that v should be equal to y over x. Now, what if you had this reciprocated? That is going to be v raised to the power of -1. That is where you have x over y, because you could actually have that also. Now the formula, you already know it, right? So you are going to have a dv divided by f of v minus v, and this will be equal to dx divided by x, basically. So because of space, I'm just going to wipe this one out. So let us go back. Now the first thing I need to do in this question, I need to make dy dx to stand in one place, right? So this is what I'm going to do. First of all, I'm going to take this to this other side. So that will leave us with x squared plus y squared dx, and this is equal to -2xy dy. Now, I need to take dx to this side, so that we're going to have dy dx. And -2xy, I need to take it away from this side, so that we're going to have an isolated form of dy dx. So as it is, I need to divide through by -2xy and dx, basically. So this is going to be -2xy multiplied by dx. So this cancels out, this cancels out, and we're going to have a -1 multiplied by x squared plus y squared. This is divided by 2xy. And on this side, we have dy divided by dx. So what can we do over here? Now we need to split these fractions, and so I think I'm going to wipe this out and do that. So this will be, so I'm going to make -1 and 2 as the coefficients, so they basically should stand up. So this is going to be 1 over 2. Now I'm going to take x squared and divide it by xy. We also have y squared and divided by xy. And on this side, we're going to have dy dx. Now, we know that x can cancel out 1x from here. And here, we can cancel 1y out. So that we should have -12. This is x over y. Plus, here we have y over x. This is equal to dy dx, right? Now we know that y divided by x, that is actually v, right? This is it. Now for x divided by v, that is going to be v raised to the power of -1. Now v raised to the power of -1 could also be written this way. This could be written as 1 over v. So that is exactly what I'm going to use over there. This is going to be -12, and here I'm going to have 1 over v, then here we're going to have v. This is equal to dy dx, right? Now we already know that dy dx, that is actually the same thing as this form, right? Now this is the same thing as this. So it ends up being, and because I want to use v, I'm actually going to use the f of v. So this should be summed this way, -1 over 2. So before I do that, let us add this together. If I had 1 over v plus v, that is basically going to be v whole number plus 1 over v. So this should be v squared plus 1 over v. That is what should be there. So this is going to be v squared plus 1 over v. So that is what should be there, basically. Then on this side, I'm going to change this and make it to be f of v, right? Because this is what we say over here. Now, having got this, we need to just multiply it and make things go exactly straight up as it's supposed to be, right? So we actually have a -1 here. So this should be a v squared, a -v squared minus 1 divided by 2v. That is actually equal to f of v. So you could actually use this, or you could use -1 multiplied by v squared plus 1 divided by 2v, and that is actually equal to f of v. So we need to place that somewhere very close because we're actually going to need it. So I'm going to place it over here. F of v, that is going to be -1, that is multiplied by v squared plus 1 divided by 2v. Now, what is the formula for solving these homogeneous equations? So we know that that should be dv divided by f of v minus of v, right? That is equal to dx divided by x. So we know that f of v, this is what it is. And that should be minus v, typically. This is the formula. So let us do that. This is going to be dv, and we're actually going to have a -1. So I'm just going to use this and FOIL the bracket. So let us just say we have -v squared minus 1 divided by 2v, and this is minus another v. So we have is equal to dx divided by x. So this is what we have. This is going to be dv divided by, now you can see that I actually have a negative here commonly, and I also have another negative there. So I can actually factor these out and keep it here. So we're going to have v squared plus 1 over 2v plus v. This is equal to dx divided by x, right? So I'm still going to add this together. So let us try to do that. Now this -1 would actually go over here because we have this to be a +1. And now you know that positive divided by negative, that is going to give you a negative, right? So this should be a -1 dv, or a minus dv rather. And this is going to be divided by this stuff. So let us work it. So here we have it as 1. So the LCM between 2v and 1, that is actually 2v. So I'm going to write it there. Okay, so if we have 2v divided by 2v, that is going to give us a 1. So this should be v squared plus 1. And if you have 2v divided by 1, that is going to give you 2v. If you multiply 2v by v, that is going to give you 2v squared. So this will be 2v squared. This is equal to dx divided by x. Now, if you have v squared plus 2v squared, that should give you 3v squared. So basically we have negative dv divided by 1 plus 3v squared divided by 2v. This is equal to dx divided by x, right? So I'm going to wipe this out. Now, this form 2v could actually get switched and taken to the numerator part. So that is going to be negative 2v dv. This is divided by 1 plus 3v squared. This is equal to dx over x. So that is actually what we have. Now, what is the final thing that we need to do? So we actually need to take this and bring it back inward. So this is going to be negative 2v over 1 plus 3v squared dv. This is minus 1 over x multiplied by dv. And this will be equal to 0. So last stuff we need to do, we need to integrate both terms of the left hand side and the term on the right hand side, which is actually 0. So how can you integrate this? We actually need to use the form of u substitution. So let's say let u be equal to 1 plus 3v squared. So what is going to be du dv? Now this is going to be a 0, and here we're actually going to have a 6v. So du should be equal to 6v dv, right? Now dv will be equal to du divided by 6v. So that is what I'm going to do. I have dv rather, and that is equal to du divided by 6v, and I also have u. So I actually need to replace this with those forms. So this is actually going to be a negative 2v. This is divided by u, and dv, that is now du divided by 6v. This is integral 1 over x dx, and here we have integral 0. So here we can find 2v divided into 6v, and that should give us 3. So I actually have negative 1 over 3 going out. So this should be negative 1 over 3. This will be integral 1 over u du minus integral 1 over x dx. This is equal to integral 0. So we know that the integral of 1 over u, that is actually ln u. So this is ln u. And this is minus integral, well, I need to clear this 3 out. Integral 1 over x, that is going to give us ln x. And over here, we can actually have a ln c. Because ln c is actually still a constant. A constant is anything that doesn't have a variable. So ln c is the same thing, right? So that is what we have there. Now we know what u is, right? U is actually 1 plus 3v squared. So this is actually going to be 1 over 3 ln. So this is ln 1 plus 3v squared. And so this is minus ln x. This is ln c. Now we also know what v is, right? We said v is equal to y over x. So if you actually want to find the solution to this problem, you need to take everything back to the original variables there. And there wasn't a v in the original. So that is why we need to do that. And before we do that, we can actually take or divide through by -1, right? So if we divide through by -1, this is going to give us 1/3. And this will be ln. We have 1 plus 3v squared plus ln x. And this will be negative ln c, right? So that is what we have. So think I can, can wipe these out. Can also wipe these out, right? Yeah. So what is the final thing we need to do? Now here we can take 1/3 and the rule of logarithm. Like that, we can actually apply that on top there. And here also we have a -1. We can actually take it to this. And that basically should be c raised to the power of -1, which is the same thing as 1 divided by c. So this should be what you should have. Ln 1 plus, now we know that v is actually y/x, so I'm just going to write that there, and this is squared. So I think I need to write this one in square brackets. So this is plus ln x, and this is going to be ln 1/c. Let me write this in square brackets, right? That is because we have a negative which became the power of c. So that is what you have.